What is glass transition? Glass transition is a physical property of food polymers. Glass transition temperature is the temperature at which an amorphous food polymer undergo a phase changes from a hard or glassy state to a soft or leathery state or vice versa. Food polymers can be protein, starch and non-starch polysaccharides including cellulose, glucans and arabinoxidants. TG is directly related to a material strength and capabilities in any given end-use application. Glass transition temperature is tied to a polymer's mechanical properties. This includes its tensile strength, impact resistance, modulus of elasticity, and its operational temperature range. Here is the journal example to have better understanding. The title is Glass Transition and Water Plasticization Effects on Crispiness of a Snack Food Extruded. A crispy snack model composed of maltodextrin with flour, salt, and water with a clearly measurable glass transition was designed and produced by extrusion. The material was used to investigate effects of glass transition and water plasticization on mechanical properties and sensory crispiness. Water sorption and the glass transition temperature range were determined gravimetrically and using differential scanning calorimetry (DSC) for samples stored at 0 to 85% RH relative humidity respectively. 3 sensory panels evaluated crispiness intensities of extruded cider. First, breaking sample with fingers, finger task. Second, beating using incisor teeth, bite task. And third, biting and chewing, bite and chew task. The extruded was plasticized by water, as observed from a typical decrease of TG with increasing water content. Changes in mechanical properties and loss of crispiness occurred at an intermediate water activity level, coinciding with the extent of plasticization, depressing the TG to below ambient temperature. The changes in mechanical properties and sensory crispiness intensities with increasing water activity had sigmoid shape following the Fermi's model. Loss of crispiness as a result of water plasticization is likely to apply to a number of low moisture food materials, although various mechanical and sensory properties do not necessarily change as unison as the material undergo a glass transition. In this journal, we learned that the glass transition temperature range and water plasticization of a cereal-based extruded snack could be manipulated by modification in the composition of the material. The maltodextrin used with wheat flour contain lower molecular weight carbohydrate, which obviously plasticized wheat flour components. This was observed as a decrease in the measured TG and improved detectability of the transition with DSC. The clearly detectable transition and the transition temperature range dependence on storage RH and water content were important criteria for the successful use of the material in investigating effect of glass transition on crispiness of snacks food.